Welcome back, and this video is on compound, look at that funny C, compound angle formula. And what this means is often we find, we know what sine x is equal to, and we know maybe what sine y is equal to, but we don't know what sine, if we add those two angles together, what that is equal to. If you can imagine in a triangle, if you've got that sort of situation where angle x, and you know that what sine x is equal to, you know what sine y is equal to. Well, what sine of those two angles added together? And it's not just as easy as going, well, it's equal to sine x plus sine y. No, it's not equal to that. Okay, and in fact, there's 6 different formula, 2 for each of sine, cos, and tan, and you've got plus and minus in there. And I can't remember them all. I just look at the formula sheet because I'll muck them up if I do. And I don't know if you can, but you've got a better memory than me if you can. So what I want to just do is go through some examples of different types of questions you might get that use these. So our first example I'm going to do is just to evaluate the exact value of cos 5 pi over 12. Okay, and the exact value, that just means not the decimal. Don't just go to your calculator, type this in, and 0.952 or nothing like that. But it's not that. We want to know the exact value. Okay. Now we know cos 0, cos pi. We know cos pi on 2. We know cos pi on 3, cos pi on 4, and that's about it. Cos pi on 6, that's about there. Well, that is it. All the values that we know, plus the sort of the multiples of these. But we don't know things like pi on 12, definitely don't know 5 pi on 12 and that sort of thing. And so if we can find two values in this set here that maybe add up or subtract to get 5 pi on 12, then we can use our compound formula to find what that's equal to. Okay, so how can we do that? Let's have a look. Could we do maybe, well, 5 pi on 12 is close to 6 pi on 12, which is pi on 2, but then we'd need to subtract pi on 12, and we don't know pi on 12, so that doesn't work. Could we perhaps do pi on 3 plus pi on 4? What would that be? That would be, so pi on 3 plus pi on 4, just checking. So if that's 12 on the bottom line, we'd multiply that by 4, you'd get 4 pi, and then here you'd multiply that by 3, and so you get 3 pi. No, that'll give you 7 pi on 12. What else could we do? Could we use a pi on 6 perhaps? Oh yes, we could use pi on 6 is 2 pi on 12, and we want 5 pi on 12, so we would want 3 pi on 12 to be added to that. And so 3 pi on 12 is pi on 4. So what we want is we want to find cos of 3 pi on 12 plus 2 pi on 12 to give us our cos 5 pi on 12. And what is this equal to? It's cos of pi on 4, just to simplify this, plus pi on 6. Beauty. Okay, let's do it. So looking at your formula, what is this equal to? Okay, so looking at your formula, just plug it in. This is equal to cos pi on 4 times by cos of the second one, cos pi on 6. Okay, and this is addition, so in the formula will be negative sine of the first one and sine of the second one. So it's straight out of the formula. So if you don't know where this is going from, look at your formula sheet. Okay, that's your formula I've just used there. Okay. Now we just got to evaluate each of these. So I'm just going to draw a little circle. It always helps me. Pi on 4 is here. Cos of pi on 4 is root 2 over 2. Cos of pi on 6 is here, and that's equal to, I'll just put these all in brackets, root 3 over 2. Okay. Minus sine of pi on 4 is also equal to root 2 over 2. And sine of pi on 6 is equal to 1/2. Okay. Let's just evaluate this. Equals root 6 over 4 minus root 2 over 4. Put them together, root 6 minus root 2 over 4. And that's your answer. That's your exact exact value for cos 5 pi on 12. And that's how you do it. Just a second example, and probably a much harder example, is if sine x is equal to 0.3 for x in pi 3 pi on 2, and tan y equals 2 for y in 0 to pi on 2. I'll just try and, I'll write here, find, just to save space because I know this is going to take me up a lot of space, find cos of x plus y. Now, if you look back at your formula for cos x plus y, what sort of things do we need to know? We need to know cos x, we need to know cos y, we need to know sine x, and we need to know sine y. Okay, so we're not even close. So far, so we need all those 4 things. So let's just have a think about it. We've got sine x, so we know that. That's ticked. We've got that one, it's 0.3, so that's good. All the others we don't know. So let's go and try to find each of these. Well, we know sine x, so I reckon cos x will be easy to find. Using our trigonometric identity, we know that cos squared x is equal to 1 minus sine squared x, which is equal to 1 minus sine squared x will be 0.3 squared, which is 1 minus 0.3 squared, 3/10 is 9/100, so 0.09, which is 0.91. Yep. Okay, so cos squared is equal to that. Therefore, cos x is equal to the square root, in fact, the plus or minus the square root of 91 over 100. Equals, now let's just, so I'll just do the square root of 91 over 10, and let's just figure out whether cos x is positive or negative. Okay, so x is in, I'll just find some space to draw like this, always like to do this, x is in pi and 3 pi, so x lives in here somewhere, and while I'm here, y is in this here, I'll just put that there. So x is in that region. Is the cosine of x positive or negative in here? In fact, it's negative, so the answer for that, cos x is negative root 91 on 10. Okay, fantastic. That's that second part done. That's cos x we've found. Let's have a look at the y's. We know tan y. How do we find cosine or sine? Okay, that is our first little dot. Second dot. What do we say? Tan y, and we want to find the others. Well, all we've got really is that sec squared x is equal to 1 plus tan squared x. In fact, I'll just write them as y, so don't get confused. I'll just copy that down off the formula sheet. Sec squared y equals 1 plus tan squared y. Oh, see, I almost wrote x again. Getcha? Equals 1 plus tan y is equal to 2, so 2 squared equals 5. So sec squared y is equal to 5. Therefore, sec y is equal to plus or minus square root of 5, and remember sec is cos upside down, and so cos of y is in this first, cos will be positive, so that must be positive as well, so it's equal to the square root of 5 because we're in the first quadrant. Okay, first quadrant. Okay, so we've got sec, therefore we can find cos, therefore cos y is just that upside down, 1 on root 5, and it will be positive as well. So there we go, there's another one, we can tick that one off. We know cos y, that's another tick, and we just need to find sine y as well. So next one, sine squared y will be equal to 1 minus cos squared y equals 1 minus this squared, so it will be 1 over square root of 5 squared. Sorry about that. Horrible 2. So that's 1 minus 1 on 5, which is equal to 4/5. Therefore, I'm not going to run out of space, it's going to be okay. Sine y is equal to plus or minus the square root 4 on 5. Haven't made a mistake, cos, sine, no, we're all good. equals, and now where's y? Y was in the first quadrant. Sine y is going to be positive, and so our number is going to be 2 over root 5, and we'll just that's 2 root 5 over 5 to simplify that. Okay, so we now have everything we need. It's a bit of work. We've got our sine y, so therefore cos x plus y equals, and I'll just write out our formula now. So again, I'm looking at my formula sheet right now. Cos x plus y is equal to cos x cos y, or cosy, minus sine x sine y, which is equal to, I'm just going to squish it in, sorry you won't do this, cos x is what? Where's that? Cos x is equal to negative root 91 over 10. This is going to get messy. And cos y was, I've lost it, 1 over root 5. I should have rationalised that. Anyway, minus sine x is, I'm losing everything. It must, oh, we already told that, so that's 3/10. And sine y was 2 root 5 over 5. So that's all your stuff, and then you just simplify that. Can we simplify it? It looks pretty horrible. I'll let you do the surds. I'm not going to sort of do it. But it's negative root 91 over 10 root 5. I'll just leave it like that for now. I'm sorry, but I'll just pick just general numbers. Minus 6 root 5 over 50, and that'll cancel down to something. Anyway, and then you just simplify. But that's your answer there. Okay, I better hurry because that's the end of the video, and YouTube only lets me do 15 minutes. See ya.